Let's learn about the factorization of algebraic expressions. An expression is something like this, or this, or this. Bunch of letters or numbers joined together by plus, minus, multiply, divide. But to learn about this, it would be useful to learn what this word means, factorization. And in algebra, factorization is the reverse process of expansion. It is the opposite of expansion. If expansion is what we use to get rid of the brackets, then factorization goes from this to something with brackets, and it takes out what's called a common factor. Let's see how this works and what the common factor is. Step 1 is to find the highest common factor of the terms, the biggest thing that goes into both. Here, my first term is 6b, and my second term is plus 12. Well, there are a lot of numbers that go into both. 1, 2, 3. 6 is the biggest number that goes into both 6 and 12. They don't have any letters in common, so my HCF is just 6. Now I can rewrite each of these things, the 6b and also the plus 12, as the HCF, 6, multiplied by something. So we said that the 6 is common to both. This part here, the 6b, I can write that as 6 times b. The 12 I need to write as 6 times something, because 6 is my highest common factor. 12 is 6 times 2, and that's where this comes from. Now we need to recognize what is common to both. What is common in both of these things? What appears in both? The 6. So, because the 6 is common to both, I'm going to bring it out the front of the brackets, and that's going to be multiplied by, well, the only thing remaining here, if I get rid of the 6, the only thing remaining in this term is b, and the only thing remaining in this term is 2. So this here is the same as that. This is the opposite of the expanding we were doing before. If I gave you this as a question before, then that would be your answer. So today, it's the other way around. We're doing the opposite process, to go backwards from the answer to the question. Let's look at this one. This one doesn't have any numbers, but we can still find something that is common. This has Q times R, and this has R times S. What is common to both of these things? R. R is in both, so I need to write each of them as R times something. QR is R times Q, and RS is R times S. So that's why I write it with my highest common factor at the front of each term. Well, now I can see what's common to both. It's the R, so I can bring that out the front. And the only thing left in this term is Q, so that would be my first term in the brackets. And the only thing left in this term is a negative S term. You can think of that negative just as coming down, or as a negative S term. Either way, that minus stays there, and the only thing left is the S. Let's try another one. 21 plus 56x. Let's think of numbers that go into both. You might, if you're good at your times tables, you might recognize that this 7 goes into this 3 times, and 7 also goes into that. There are no letters in common here. So the HCF is 7. 21, we need to write 21 as 7 times something. 21 is 7 times 3. 56x is 7 times 8x. Now, the thing that's common to both is the 7, so I can put the 7 out the front, and it's going to be 7 multiplied by, well, the only thing left here is a 3, and the only thing left here is an 8x term, a positive 8x term. So 7 bracket 3 plus 8x. You can imagine if I did this as an expansion question, I would get 7 times 3 is 21x, 7 times 8x is 56x. Okay, this one here, we don't have any numbers, so we don't have to worry about numbers being in common, but we do have letters. What a letter is in common to both this term and this term? It's an x. So x is common to both, so I need to write each of these, I need to rewrite each term as the HCF multiplied by something else. So x is x times 1. And xy is x times y. This is a weird way to write x. It's the same as x, But the reason I'm doing it this way is so that I can really easily see that this is an x times, and this is also an x times. So then I can see what is going to be left to go inside the brackets. The x times is common, so that will go out the front. This one, there's only a 1 left, and here there is a minus y left. Alright, so the x is common to both and goes here. The only thing left here is a 1, and the only thing left here is a negative y. Okay. Whew. This one looks crazy, doesn't it? It's got 3 terms, 2 different kinds of letters, they all have numbers. This one is a bit trickier, so we can do it in more steps. First, let's write each of the 3 terms. We've got 2ab squared. If I break that down into all of the factors that make up 2ab squared, well, the 2 times a, b squared is b times b. So if I break that up and put multiplication signs between all of them, those are all the parts that make up 2ab squared. We can do the same for 6ab squared. 6, I can break 6 down into 2 numbers. What are the 2 numbers that multiply together to give 6? They are 2 and 3, right? So I can break 6 into 2 times 3 times a times b. And finally, 8. If I want to break 8 into prime factors, so into numbers as small as possible that multiply together to give 8, 8 breaks down into 2 times 2 times 2. A squared is a times a, and the b, well, just on the end as a times b. Whew! Okay, you can see why we're doing this in steps, right? Now we need to recognize what is common to these 3 things. Things that are common to all 3. Can you see one thing that is in all 3 expressions? There is a 2 that it's in all 3 expressions. So we can, circle them, highlight them, so we know we've done that one. All right, looking at the rest of it, is there something in common that's in all 3? Well, yeah, we've got an A is in all 3. Okay, now looking at the bits that I still haven't highlighted, b times b, 3 times b, 2 times 2 times a times b. What is common to all 3? What is in all 3 expressions? The b. I can't do any more because now, there's just a b left here and that doesn't appear in all the other ones. So that's as much as I can do. So the highest common factor is 2 times a times b, or 2ab. So I need to write, well, at the front, I've got 2ab, bracket, I could go through and try to do the same thing I did here and split it up, but I've already done that. I can already see what is the same about this one. The same is 2ab, and what is different. The different part is b. And similar for this term, this plus 6ab, the same is 2ab, and what is different in this term? The different part is a 3. So this will be a plus 3 for this term. And for the last one, I've got 2ab, that's in common, that's the same as the others. Which parts are different? Which parts aren't highlighted? I have 2 times 2 times a. And 2 times 2 times a is 4 times a. So that's why the answer is 4a. This one you can see is really tricky, but it is possible if you do it in steps. Yeah. So have fun with the questions. Let me know if you've got any questions and I can help you out. Have fun factorizing. Bye everyone.